So Surds, again, this is revision from GCSE. I remember at GCSE, Surds was probably one of the most horrible topics for me. Basically, a surd is, so obviously the square root of 4 is equal to 2, and the square root of 36 is equal to 6. Let's take the square root of 2. Well, there is no square root of 2, or it's not clean anyway. If you put it into a calculator, it will come up with a decimal point 1.4. I'm not sure if that's right, 1.41, something like that. Well, it's actually useful to keep it in this form of root 2, and you actually get pretty much loads of surds. So root 2, root 5, all of these are surds, and it's useful to keep them in the form of the square root. Um, a surd is basically a square root of a non-square number. It is very useful to express large surds as multiples of smaller surds. So you can express stuff like 6 root 2, which is 6 times root 2, 10 root 10, which is 10 times root 10, etc., etc. We can do this because of surd laws. Surd laws are, there's two you need to know of. One is that the square root of AB is equal to the square root of A times the square root of B, and that's number one. And secondly, that the square root of A over B is equal to the square root of A over the square root of B. So why is this useful? This is because we can make surds. We can make smaller surds from larger surds. So for example, let's take root 20. Now, we want to find the largest square number factor of 20. So let's list all the square numbers below 20. So 16, 9, and 4. We don't really bother about 1. Um, 20 is not divisible by 16. It's not divisible by 9. It is divisible by 4, though. 4 times 5 is equal to 20. So we can write this as 5 times 4. And due to the Surd law, which is number 1 over here, we can rewrite this as 5 times root 4. Well, root 4 is just 2, so it becomes root 5 times 2, which is equal to 2 root 5. And this is very common in maths, and it's very useful for us to use. Take another example, take root 72. So let's list all the numbers, let's list all the square numbers under 72. So we've got 4, 9, 16, 25, 36, 49, and 64. 64 is not divisible by 72 is not divisible by 64, neither is it by 49. However, 72 is divisible by 36, so we can rewrite this as 36 times 2, which is what you times 36 by to get 72. We can rewrite this as root 36 times root 2, which we can rewrite as 6 root 2. Over time you'll get better and better at this, to the point where you don't need to write out all the square numbers every time. But remember that I said that surds was one of the most horrible subjects at GCSE for me. Well, it's not anymore. One, because A-level maths can give it hard, but two, because literally your calculator can do it for you. You don't really need to know how to actually make surds anymore. If you just put the square root of a number into your calculator, let's say square root of 50, and you press equals, your calculator will give you the lowest surd that it can. So in my instance, it is literally just put root 50 is equal to 5 root 2. So you don't actually really need to know how to do any of this, because the calculator will literally do it for you. And I find it almost impossible, again, even in an AS exam, for them to ask you to a surd question asking for your full working. I think a calculator will be able to do it, and you won't lose any marks. Just a couple of other notes. First of all, the root of x, or the surd of x, times the surd of x is equal to x. in the same way in which the square root of 2 times the square root of 2 is equal to 2. That seems obvious, but there's a lot of people, including me, who has forgot about that before. I also just want to highlight again the technical difference of squares of x minus y, which is equal to the surd of x plus the surd of y, the surd of x minus the surd of y. This becomes a bit more important in the next topic in the video, which is rationalising denominators.